So we're given, and we should know this anyway, but 1 over 1 minus x is the summation from n equals 0 to infinity of x to the n. And so we want to find a series representation for this. And if you remember, if we take the derivative of this, we get 1 over 1 minus x squared. So that means that 1 over 1 minus x squared is equal to the derivative of what you see here. Well, we bring the n down, times x to the n minus 1, summation. For this to work, we know we're going to have to start at 1. Because I know that, like, when I have this, I'll have 1 plus x squared plus x cubed. That's what this one's going to be. When I take its derivative, the derivative of 1 is 0, the derivative of x is 1, the derivative of x squared is 2x, 3x squared, etc. And the only way for this to work out is if I start at 1 to infinity. So now when I do this, x to the 1 minus 1 is 0, n times 1 is 1. When I plug in a 2, I have 2 times x to the 2 minus 1. Well, that's my 2x, my 3x squared, etc. So the only difference between these two is that this one gets multiplied by an x. If I multiply this by x, then I'll have this. So I'm going to take this series and multiply it by x. What am I going to get? Everything here gets multiplied by x, and I have x plus 2x squared plus 3x cubed plus dot dot dot. Or when I multiply this by x, I have the summation from n equals 1 to infinity of n times x to the n minus 1 times another x. Well, that's really equal to, when I add my exponents, this is to the 1 power, so I have x to the n minus 1 plus 1. Well, those just cancel out, and I'm left with n times x to the n. That is the series representation for what you see here.